So, in this problem, so the system produced ice at negative 12 degrees Celsius from water initially at 30 degrees Celsius within 24 hours. So, heat losses are equal to 18% of the heat absorbed from the water. So, we are required to determine the compressor power required. So, this is our given. So, first, ice production we have 10 tons per day. So initial water temperature is 30 degrees Celsius. So initial water temperature ayan. Final ice temperature naman is negative 12 degrees Celsius. Our losses is 18%. So kanina nasabi ko na yung refrigerant properties, which is 1437 kilojoule per kilogram for H sub 1. So for H sub 2 is equals to 1736 kilojoule per kilogram. And next, our H sub 4 is equals to 366 kilojoule per kilogram. So constant specific heat of water, we all know it's 4.187 kilojoule per kilogram Kelvin. Latent heat of fusion, 335 kilojoule per kilogram. And then the specific heat of ice is 2.0093 kilojoule per kilogram Kelvin. So now we are going to convert ice production rate to kilogram per sec ulit. So let's start here. So 10 tons. Yan. Since 1 day is equals to 24 hours, and then multiplied by 907.44 kilogram over 1 ton. So 1 hour over 3,600 seconds. So lagay mo lang siya sa calculator, yung mga given. Yung makukuha mo is 0.105 kilogram per sec. So next, we are going to calculate heat removed from water. Yung 30 degrees Celsius to 0 degrees Celsius. Oh my god. So the formula for this is Q1 is equals to mCpW delta T. So substitute mo lang ulit yung values for this. 0.105 multiplied by 4.187 multiplied by 30. So our Q sub 1 is equals to 13.19 kilowatts. So unit analysis for this, kilogram per sec multiplied by kilojoule per kilogram Kelvin multiplied by Kelvin, ayan, kilojoule per sec, and then yan, cancel lang. So yung makukuha natin is kilojoule, and then the second. So we all know that kilojoule per second is equals to kilowatts. So this is our Q1. So for Q2, parehas lang din kanina dun sa problem 2. Q2, formula for this is Q2 is equals to MLF. So substitute 0.105 multiplied by 335. So our Q2 will be 35.18 kilowatts. Gaya din ulit kanina yung unit analysis for this kung bakit siya naging kilowatts. And then next, for Q3, same as kanina, it is equals to MCPI delta T. So substitute ulit ng value. 0.105 multiplied by 2.093 multiplied by 12. So 2.64 kilowatts. So this is for Q3. And for unit analysis for this is same as kanina. And then we need to compute ulit our total heat absorbed. So kanina, di ba, Q basis is equals to Q1 plus Q2 plus Q3. Yung mga na-compute natin from Q1 to Q3, lalagay lang natin siya here. Substitute lang natin sa value, yung value, which is 13.19 plus 35.18 plus 2.64. And then, ang makukuha natin is 51.01. Since mga lahat sila naka-kilowatts, so kilowatts ang ating unit. So, next, kailangan natin i-add yung 18% na loss sa ating problem. So, QL equals to 0.18. Ayan. And then, i-multiply mo siya sa yung sa Q basis niya, which is the 51.01. So, our QL will be 9.18